Today we take you inside the world-leading manufacturing initiative of SANY Group, their global lighthouse factories. Selected by the World Economic Forum's Global Lighthouse Network, these factories represent the highest benchmarks in intelligent manufacturing, digital operations, and heavy industry transformation. A lighthouse factory is more than just automation. It integrates AI, IoT, robotics, and big data across the entire production line. For example, SANY's Beijing drilling machinery plant became the first heavy equipment factory globally to be certified as a lighthouse factory, thanks to AI-driven logistics, 5G-guided vehicles, and material flows that cut lead time by 77%. Recently, SANY's Changsha No. 18 factory added to the network, with full automation of 9 major processes, 540-plus sensors, 200-plus robots, and dramatic productivity gains, 123% increase in capacity, 98% improvement in labor efficiency. Step into the shop floor where massive components, steel frames, excavator booms, pump trucks, move through an orchestrated flow of robotic welding, laser cutting, AGV transport, and end-to-end digital tracking. Every product is assigned an ID card at birth, tracked through processing, assembly, inspection, and shipping, ensuring full traceability and quality assurance. From plate warehouses to welding cells, the visual harmony of machines, humans, and data streams underscores the new era of Industry 4.0 in heavy equipment. In a world where heavy machinery demands are rising, SANY's lighthouse factories show what's possible when scale meets smart. These facilities are not just building excavators and cranes, they are building the future of global manufacturing, resilient, efficient, and digitally native. Welcome to the future of automated steel fabrication, where robots no longer wait for programmers. This is a self-programming robotic welding system that combines vision, AI, and precision motion control to weld structural beams with remarkable accuracy. First, the operator selects beam assemblies and loads accessories onto a conveyor tray. Each accessory is 3D scanned and validated before the robotic system begins. Smart manipulators and trolleys automatically position themselves to prevent collisions, while beams are scanned to compensate for any distortion. With data-driven alignment, every component is placed and tacked with perfect precision. Then, vision-guided robotic welding takes over, executing flawless, repeatable welds on all sides. The beam rotates for full surface access, ensuring each seam meets industrial-grade strength and finish. When complete, the welded assembly is automatically delivered to the unloading zone, a seamless workflow of automation, intelligence, and craftsmanship. This is the new era of fabrication efficiency, powered by self-programming robotic technology. Deep beneath the ocean's surface, miles of heavy-duty steel pipeline carry the world's most valuable resource, energy. Before a single drop of oil or gas ever travels through them, each pipeline section must endure a construction process defined by precision, strength, and absolute reliability. This is offshore pipeline construction, where every weld, every joint, and every inch of steel must perform perfectly under immense pressure and corrosive seawater for decades. The process begins at the pipe-lay barge or coastal fabrication yard, where hundreds of thick steel pipes await assembly. Each pipe end is carefully beveled, forming a precise V-shaped edge that ensures deep penetration and flawless fusion during welding. Once beveled, the pipes are cleaned and inspected, then moved to the bead stall for the next crucial phase, preheating. To achieve an ideal weld, the steel must reach a controlled temperature that evaporates all surface moisture and stabilizes the metal's internal structure. Technicians install a preheat band, adjusting it to the exact distance required, before bringing the pipe to the qualified temperature range. After preheating, the pipe is transferred to the firing line, the production zone where alignment and welding occur. Here, the reach rod is inserted into the next pipe section to ensure axial precision. Operators synchronize their actions. Clamps are positioned, shoes are locked, and the pipe ends are drawn tightly together. When the alignment is perfect, the spacer signals readiness with a sharp tap, and the system secures the joint in place. It's a choreography of precision, with each motion timed down to seconds. Every adjustment must be flawless, because even a fraction of a millimeter can compromise the weld integrity once the pipeline is submerged. With everything aligned, welding begins. Assistants position P600S welding units along the pipe bands while the welder performs the root and hot passes, fusing both sides of the bevel with intense arcs of light and molten steel. The sound of the torch cutting through metal fills the air, a mix of heat, power, and precision. In the second welding station, the pipe is filled out and capped with multiple passes, ensuring a uniform bead that can withstand oceanic pressure and thermal expansion. Every joint is inspected visually and by ultrasonic testing to detect even the smallest imperfection. For more than 3 decades, BlueScope Welded Products in Unanderra, New South Wales, has stood as a cornerstone of Australia's steel manufacturing industry. Behind every beam and plate lies the dedication of a skilled workforce, many who have spent their entire careers mastering this craft. From humble beginnings, these men and women have built a legacy of precision, teamwork, and industrial pride. Here, the process begins with raw steel plate delivered directly from the nearby plate mill, ranging from 10 to 40 millimeters thick. The plates are flame-cut to specification using oxyacetylene cutters, blasted clean to remove rust and scale, and matched for assembly. Each beam is tack-welded with extreme precision to maintain perfect web height and alignment. Then, sub-arc welders take over, depositing continuous welds on both sides, ensuring strength, balance, and compliance with BlueScope's rigorous structural standards. Once welded, the beams are straightened, cut to length, inspected, and dispatched directly to customers. From raw plate in the morning to a finished beam by the afternoon, the turnaround is fast, efficient, and exact. With a diverse team working around the clock across multiple shifts, safety and quality remain at the heart of every operation. BlueScope Welded Products continues to shape the future of Australian steel, combining craftsmanship, innovation, and the enduring spirit of its people. For more than a century, Lingen & Sonderman has produced high-performance springs for the global railway industry. From passenger comfort to heavy-load transport, these springs support some of the world's most demanding rail applications, trusted by major manufacturers such as Bombardier, Siemens Transportation, and Alstom. One of the most critical steps in their production is shot peening, a hardening process that dramatically increases durability and fatigue strength. After heat treatment, each parabolic spring must be cleaned and descaled. AGTOS supplies the advanced shot peening units that power this phase. The workpieces travel on a closed-loop roller conveyor, where the loading and unloading point are identical, maximizing workflow efficiency. Before peening begins, the springs are pre-cleaned, and their surfaces ground to remove any slag or imperfections. Each carrier holds 2 springs at a time, manually exchanged by the operator. Once the protective cover rises, the spring is placed under tension beneath a robust hold-down device. A massive 20-ton press force applies the required pre-tension with a vertical stroke of 200 millimeters, preparing the steel for uniform hardening. Sensors along the conveyor automatically trigger each step as the springs move through the system. As they enter the blast zone, the tension surfaces and edges are hardened at feed speeds between 3 and 10 meters per minute. The vestibules are lined with heavy, wear-resistant rubber curtains to prevent blast media from escaping. A noise protection booth nearby reduces sound from 90 decibels to 80 decibels, creating a safer workspace. Inside the chamber, the AGTOS high-performance turbines deliver intense, controlled, shot-peening energy. The turbines begin in idle mode, ramping up only after the workpieces enter, saving energy and avoiding unnecessary media wear. 5 tons of rounded wire shot are stored above the system. After blasting, used shot falls into a hopper, where a screw conveyor and bucket elevator transport it upward for cleaning. An air classifier removes dust and undersized particles, while AGTOS cartridge filters capture and dispose of airborne contaminants. A secondary safety filter ensures exhaust air is clean enough to be returned directly to the production hall, conserving valuable heating energy. The leaf and coil springs produced here are used extensively across the global rail network, delivering comfort, stability, and safety to millions of passengers. With AGTOS blasting and shot-peening technology at the core of their process, Langen & Sondermann continues to achieve world-class durability and performance. Here in Algeria, at SME's facility, the MH365i CNC plate rolling machine is hard at work, transforming flat steel plates into curved, pre-formed segments ready for heavy fabrication. This machine represents the fusion of hydraulic power and CNC precision to handle demanding plate forming tasks. The process begins by loading a sizable steel plate onto the machine bed. The CNC system calculates the target curvature and roll path. Dual bottom rolls and an upper adjustable roll apply force in a controlled sequence, bending the plate uniformly. Progressive passes reduce flatness, correct edge deformation, and refine the bending radius until the plate approaches its design curve. Systems like the MH365i enable high repeatability and minimal operator input, ideal for structural shells, tanks, or large diameter cylinders. With its CNC integration and robust hydraulics, this plate roll boosts throughput, reduces scrap, and supports precision manufacturing for heavy industries. Whether forming hulls, tanks, or structural segments for oil and gas or infrastructure, this machine shows how modern plate forming meets scale and accuracy. Ever wondered how those square steel tubes used in construction, machinery frames, and infrastructure are made? It starts from flat steel strips, coils of material that go through high-precision forming, welding, and sizing to become structural square tubing used everywhere. First, the steel coil is slit to the correct width. The strip is then fed into forming rolls, where the edges are brought together and a weld seam is created, typically by electric resistance welding, ERW for welded tubes. After the round tube is formed and welded, a set of square forming rolls reshape it into the square hollow section. This process ensures a consistent shape, tight corner radii, and uniform wall thickness across the length of the tube. Once formed, the tubes pass through sizing and straightening machines to correct any distortion and ensure dimensional accuracy. Straightness within millimeter range. They are then cut to length, surface treated if needed, such as galvanizing or painting, and inspected for quality, weld integrity, wall thickness, shape tolerance. The finished square tubes emerge ready to be used in structural frames, scaffolding, machinery, or architectural applications. From flat coil to square section, this streamlined production line delivers ready-to-use structural elements with precision, strength, and repeatability. These tubes form the backbone of countless buildings, machines, and infrastructures, the unseen framework of modern industry.